Number 7. On the basis of individual bond polarity and orientation, determine whether each of the following molecules would be polar or nonpolar. So the individual bonds, and the orientation of those bonds. A, water is going to be polar. Okay, the dipole moments are both going to be pointing toward oxygen, but because the lone pairs of electrons on oxygen are driving those bonded hydrogens down, they're not going to be oriented in such a way that they cancel each other out, making it polar. Iodine, that's just two iodines bonded to one another. It's a straight across bond. That's going to be nonpolar. CF4 for C is going to be nonpolar because while there is an okay difference in electronegativity between carbon and fluorine, right? It's a 1.5. It's a somewhat large, a larger-ish electronegativity difference. These are going to spread out in 4 different directions, and they will all cancel each other out. They're all going to perfectly balance each other out because they're spreading out in each of the different orientations, and so they will average each other out, making it nonpolar. So here the individual bond polarities are polar, but because of the orientation of the fluorines, they actually balance each other out, and so the overall molecule is nonpolar. In H3, the individual bonds, right, 3.0 to 2.1, are going to be polar. And because of the lone pair of electrons on the central nitrogen, those bonds are going to be driven down at an angle, and so they won't be able to balance each other out. And so you're going to have a polar molecule there. CO2, if you remember appropriately, CO2 is going to be a linear molecule with one oxygen on each side. And so the bonds will be decently polar, right? So we got a 1.0 electronegativity difference between carbon and oxygen. But because it's linear, they cancel each other out, becoming nonpolar.